Good morning, girls. Today's our lecture is on embedded operating system, which is on scheduling. Now, this is the last two lectures. We have seen the function of process and the management, memory management, and the process management. Today, we will see the how the process is scheduled. Right? It's a scheduling. In that topic, we are going to see the process scheduling, priority scheduling, multiple process system, queue per process, and workload balance. How the processor means CPU or the microcontroller will balance the workload. Today's our process is our topic is on the basis of scheduling. How the multiple process can be scheduled in a single core processor or a double core processor or quarter core processor. Now, the process scheduling means what? The objective. What is the objective of multiple programming is to have some process running at all time to maximize the CPU utilizations, right? There are n number of process in a programs, right? Sometimes we have to take the input data, sometimes we have to throw the output data on the output ports. So during that time CPU doesn't work, but if it is a multi-process, so the process can be utilized, the CPU can be utilized for each and every process simultaneously. So we can use the maximum utilization of CPU. The more main objective of this operating system is to utilize the proper resources, right? Whatever microcontroller CPU is also one kind of the resources, right? Microcontroller that has to be properly used for all other process and will get the maximum throughput, right? The objective of time sharing is to switch the CPU among the process. Means CPU means your microcontroller is shared among the process, so the frequently that user can interact with each other program while it is running, right? So user will interact each and every applications or program. Suppose I'm just giving one example. You are listening music, by the time you are typing something into the word, by the time your net surfing is going out. Now three applications are there, so you are continuously listening music, means your CPU is engaged with that, and then you are typing on the word pad or word documents that time. So but that process, CPU is only one CPU, your microcontroller is one, or the CPU is one, but that process will taking one by one in a round robin mode. You will not feel that I'm doing only one work or two work, but it is share among, so user cannot interact with each other program while it is running, right? So we can use the maximum applications simultaneously, right? To meet this objective, the process scheduler select an available process possible for setting several available process for the program on the executions. To meet these two objectives are very important in scheduling, right? Which one is the objective of multi-programming is to have same process running at the all time. Some process are running at the all time to maximize the utilization. Some process means a one n number of process is running at the same time, so to utilize the maximization CPU, right? And the second objection is that process has a time sharing is to switch the CPU among the process, so the frequently that user can interact with each program while it is running. So these two objectives are very important. To meet this objective, the processor scheduler select an available process possible to set a several available process for the program executions on the CPU. For single processor, nowadays it comes dual processor, quad processor, octal processor. But for single processor system, there will be a never more than one running process, right? Single processor, at that instant only one process is running, right? If there are more process, the rest will wait until the CPU is free and can be rescheduled, right? So all other processors are in a queue. If one process is running at one time, other process is in a queue. So queue in wait, queue to have the wait, that is called the ready process, right? Now this is the scheduling queue. How it is stand into the scheduling queue? It's a just simple example, normal way. When we go to the ticket counter, we stand in a queue. Some job queue and some ready queue. Job queue means what? All the processor entered the system, they are put into the job queue, and which consists of all the process in a system, right? So the all process are standing into the job queue, right? All process enters the system. So whichever the process is entered the system, they all are put it into the job queue, and which consists all the process in the system, right? But the ready queue means what? The process that a job queue may, what is, some are the block process, some are the suspended process, so all these are in a job queue, right? But the ready process is what? The process that are residing in main memory and are ready and waiting to execute, are keeping on the list, are called as the ready queue, right? Those are unblocked process, they are standing into the ready queue and waiting to get the CPUs, right? Waiting to get the microprocessor. So this is your CPU. Just see the example. We are standing on a queue, and then this is the ready positions, one by one it takes, and then but the job queue, whichever the system is occurred, right? And all are into the job. So all are into the job queue, but those are into the job queue, they all are not into the ready queue, because in ready queue the block processor will not be there, the suspended processor will not be there, or any waiting for input output instructions, that process will not be there. Only ready processor to get the CPU executions, that is only the ready processor. This is a scheduling queue. When it is a scheduling queue, so this kind of processor will be there, right? Now we can see the example of this by the scenarios. This is your ready processor queue, right? This is the your job processor will send the ready process to the ready queue. It execute the CPU. If it is over, it will exit, right? It is end. But that process requires some input output devices instructions. It will send to the input output waiting queues, right? So input output will take the data input output. If it is finished, and it will stand into the ready queue, right? Or some other process will come to the CPU. It will get the timeout, right? Each and every process is given a timeout. We'll see the example of scheduling, right? So the timeout, then it will swap into partially executed swap out the process. Still the process is not over, but whatever the time is given, that particular process, that time is over, so it will swap and it will put it into the partial executed swap out process. Again that process will stand into the queue ready. So whenever this process will get a chance to get the CPU, again it will execute, again it will swap, and then when the process is over, so it comes out of the CPU, right? Now this is the scenario. What is scheduling algorithm, right? They have the different kinds of algorithm over there. So these all are the algorithms which is written in a embedded operating system or any other general purpose operating system. So now in our scenario, we have to see the priority scheduling. What is the advantage and what is the disadvantage of priority scheduling? Each process has a priority, as we have seen in our this. When we create the task, we give the priorities of that task. Highest priority, lowest priority. Those are have the highest priority. They will get first chance to execute. Practically, also we have seen. Now The priority scheduling is what? The priority is associated with each process. Each process means with each task, right? And the CPU is allocated to the process with the highest priority, right? So always CPU or the microcontroller will execute the process which are having the highest priority. This is the general fundamental as we have seen, right? Equal priority process are scheduled in a first come first service order. If two process has the equal priority, right? So but whichever the comes first, they will take first, and first come first service basis, right? Now thus and short job finishing algorithm is simply priority algorithm. Short job finish, it's simply priority algorithm where the properties is inverse of the predictal next CPU burst, right? So what is the advantage of this priority scheduling? Those have the lowest priority, they might get the chance to process the into the CPU, right? But if each and every alterations of algorithm priority, if we change the priority of lowest priority to better one the highest priority, so that job can be executed by the CPU. So the larger CPU burst means what? The CPU time, how much time that process has to be in a CPU, the lowest priority and the vice versa. The largest time of the CPU, if that processor is given the largest time and the lowest time priority, so that process might not get chance to execute into the CPU. So now the priority scheduling can be either primitive or non-primitive. Primitive means what? It is a standard, whatever we have assigned, the same priority they will change. Non-primitive means what? While alteration of one cycle of this process queue, next process queue, better priorities is change. That is non-primitive. That's why we have one example of, in a practical, we can set the priority while the runtime and we will get the priority while the runtime. So while programming, we can change the priority of the task, means we can change the process of task for process priority. That is called the non-primitive, right? A permissive priority scheduling algorithm will be permit the CPU if the priority of the newly arrival process is higher than the priority of currently running process, right? Why? Because of that process is waiting till time, even though it doesn't have the higher priority, and the new arrival process has a highest priority than that. So that will change the old processor priority will change, and it will get the priority to the execute. So that is called the primitive priority, right? Primitive priority, it will change the priority of the task or of the process while it is running, and it gets the chance to execute the CPU even though newly arrival process is higher priority than the current processor, right? Now, a non-primitive priority scheduling algorithm will simply put new process at headed of the ready queue, right? If it is new process is arrival and that has a highest priority, so that new process will get the first chance, and then the next process will get the whenever their turn will come, that time they will get the priorities, right? That is the non-primitive, means as it is non-randomly is going on. Right now, today we will see one example, so it will clear more doubts if we take this example or take these scenarios, right? Consider the following set of process assuming to arrival at zero time, right? It will arrive at zero time. In order to, these are the process, right? P1, P2, P3, P4, P5. So these are the process P1, P2, P3, P4, P5, right? With the length of the CPU burst time in a millisecond. Burst time means P1 is needs 10 millisecond to complete their job, right? P1, P2 will need 1 microsecond to complete their job, right? P3 will need 2 microsecond, P4 will need 1 microsecond, and P2 will need 5 microsecond to complete their job. Please, whose mic is voice is there? So P5 is need 5 microsecond. Now along with that, each process has given the priority, right? So P1 has third priority, P2 has 1 priority, P4 has 4 priority, P5 has 5 P4 has 5 priority, and P5 has 2 priority. Now here it is taken, 1 means it is highest priority it is taken, but while we are performing a practicals, we have the Orta's library is written in that way कि those has the highest number that has the highest priority, right? So please don't confuse in this, right? Here we have taken 1 is a highest priority and 2 is that lowest priority than the 1, and 3 is again the lowest priority than 2. So we are taking the order of 1, 2, 3, 4, 5, 6 highest priority. But while we are performing the labs, because in Orta's library they have taken the 5 is the first priority, right? So please don't confuse in that and this. It is given, it is already written, or they will instruct you which is the highest priority of that. Okay. So now this is reason, first we have to make there the Gantt chart. So first we have to arrival time of all the processes 0 time, but which processor is the highest priority? P2. And how much time it will take? P2 will take 1 time, 1 millisecond. Then second priority is 5 P5. After 1 millisecond, CPU's time is 5 millisecond is for P5. Then it is third priority is P1. So after P2 it will take the P1, it is 10 millisecond. After P1 it will take the P3 that has the fourth priority, it will take the 2 millisecond, and then after last priority P4 it will take the 5 millisecond. So it is the using priority schedule, we schedule this process according to the following Gantt chart. This is called as the Gantt chart. All the processor has arrival on P0 time, right? But which processor CPU has taken, those have the highest priority. The P2 has the highest priority. From 0 to 1, it is P2 will execute. From 1 to 6, because it has a 5 millisecond. So 6 minus 1, it takes the 5 millisecond. P5 is executed. After 6, it is P1 and it requires the 10 milliseconds. So 16 minus 6. So the 10 millisecond P1 is executed, right? Then which priority is there? P3. P3 is a 4 millisecond. So 16 2 millisecond, it has a 4 priority. So 18 plus 2 is 16, and P5 P4 is 19 millisecond. So total 19 millisecond it's required to execute, but P4 waiting time is 80 millisecond, P3's waiting time is 60 millisecond, P1's waiting time is 6 millisecond, and P5 waiting time is 1 millisecond, and P2 waiting time is 0 millisecond. So we have to call that, calculate the average waiting time of whole process, how much time it's waited. So waiting time of P1 is 6 millisecond, waiting time of P2 is 0 millisecond, waiting time of P3 is 16 millisecond, waiting time of P4 is 18 millisecond, and waiting time of P5 is 1 millisecond. So now if we calculate average, so sum of all time divided by 5, so each and average waiting time is 8.2 milliseconds. That much time is required, right? Now we'll see what is a problem with priority scheduling, right? So this is the scenario of scheduling, what we are, how the process are into the scheduling, and how the process are waiting. Now what is the priorities problem, priority scheduling, how it is recovered? The major problem with priority scheduling algorithm is indefinite blocking or stagnations. Indefinite blocking, if the lowest priority is there, so it is indefinite blocking time, because the highest priority task will come and the CPU will execute according to their priority, and those are have the lowest priority, they might get chance or they might don't get chance to execute into the CPU. That is the priority scheduling problem. The process that is ready to run but wait for the CPU can be considered as a block, right? It is processor is ready, why don't I get the time to execute into the CPU? It's ready, but it is doesn't get the chance to, it is waiting for the CPU, can be considered as a block, right? The priority scheduling algorithm can be some low priority process waiting indefinitely, right? In a heavy loaded computer system or any microcontroller system, embedded system, the steady stream of the higher priority process can be prevented a lower priority process from getting from ever getting the CPU, right? This is the major problem of the priority scheduling. That's why the concept is come primitive and non-primitive. The how to solve this problem, right? A solution to the problem of indefinite blocking of lower priority process is again and aging. Aging means what? A process is aging, those have much time to waiting into the block state even though high priority processor is arrived, so that aging, those have the waiting time is more, so that process will get the chance. That is a solution for the priority scheduling. Aging is the technique of gradually increase the priority of process that wait in the system for the long time. It is gradually means it is primitive. It is gradually increasing their priority. If it is the process is long time, so at one moment that process will get the chance to execute into the CPU. So that will not be indefinite blocking mode. That process will not be indefinite blocking mode. So that will be the solution for the priority scheduling, right? Now we'll take this one more example is there. Consider the setting. It is given the priority, it is given the arrival time of all the processes different. So we'll see this example. Consider the set of process with arrival time in a millisecond, CPU burst time in a millisecond, and priority 0 is the highest priority. It is written over there. The 0 is the highest priority shown below. None of the process is having input output bus, means none of the process is going to the this mode, input output bus, this mode, right? None of the process is going to the input output burst mode, right? Now, and the average waiting time in a millisecond of all the process using the primitive means what? The priority is not changing. Primitive priorities and scheduling algorithm is, right? Now we'll have to consider primitive priorities means what? So the primitive priority scheduling will permit the CPU if the priority of newly arrival process is higher than the priority of current running process. Huh. The The primitive priority scheduling algorithm will permit the CPU if the priority of the newly arrival process is higher than the priority of current running process. Still it will execute that process, right? So this is the primitive priority. So the we'll have to calculate how much millisecond is waiting time. Now first we have to arrive these Gantt charts as according to the priorities P1, P2, P3, P4, P5. Their arrival time is 0, then arrival time is 2 millisecond, then arrival time is 5 millisecond of P2, then arrival time is 9 millisecond, then arrival time is 12 millisecond. This is the arrival time is given. It is not all the processor will arrive at 0 time. So if it is arrive at 0 time, then we'll have to check the priority. Arrival time along with the, we have to check the priority, and then there the burst time, right? Now we'll see that. So this is arrival time. P1 will arrive at 0, then which is 2 millisecond. It is arrived P4, then after 5 millisecond, even it is not completed because P2 is 2 millisecond, but 10 millisecond it is required. But after 5 millisecond, it is P2 is arrived. After 33 millisecond, it is P4 is arrived and P0. Now we'll see this Gantt chart. Just a minute. Now see, logically you need to think that this is P1 is 0 time, right? It requires the 11 millisecond, but it has the highest priority P2. It is priority is 2, right? No other process will arrive in a 0 time, right? Only the P1 is arrived. So the P1 is arrived at 0 time. So it takes the 2 millisecond P1 process, but P4 will arrive at 2 millisecond and it has the highest priority than the P1. So what? P1 will execute only 2 millisecond and it will come out of the CPU and it will take the P2. And P2 is highest priority 2 millisecond, right? So it is execute the P2 2 millisecond, right? After it is 10 millisecond, but after 5 millisecond, so how much time P4 will execute? 3 millisecond. After 5 millisecond, P2 will arrive, right? P2's burst time is 28 millisecond and it has the 0 priority, right? It is the highest priority. So the whole P2 will execute, right? So after 12 millisecond, which is P3 will arrive, but P3 has the lowest priority than the P2. So the first P2 will execute and then it will take the P4 again. P4, why it is P4? Because P3's priority is 3 and P4's priority is 1. It is highest priority. So first P2, P4 will completed. Now here P4 will completed for 3 millisecond. 5 minus 3, 3 millisecond. So how much time is required? 7 millisecond. So now here 33 plus 7 is 40 millisecond. Till 40 millisecond P4 will execute. Then the P1, then the two process are there on the queue. So one is P1 is there, one is P3 is there, and one is P9. So the P5 has the last priority. It will complete the last. But among that P1 and P3, so the P1 has the highest priority. So first it is completed the P1, whatever the left time, here the 2 millisecond, then the 9 millisecond is required. So 40 to 49 millisecond P1 will take. Then after P3 will take, how much time is P3? Only 2 milliseconds. So 49 to 51 is P1, P3 is takes. And then in last priority is P5, that is the 9 millisecond. So 51 to 69 is P3. So the whole process will 2 times your P1 it is into the queue. Your P4, P2 is also P4, P4 will come 2 times. P2 will execute once time because it has a highest priority. P3 is the lowest priority, P5 is the lowest priority than the P3. So this is your Gantt chart. Now we'll have to calculate the waiting time, right? Now the waiting time is equal to total waiting time minus number of millisecond process execute minus arrival time, right? So this is a formula of waiting time. So how we will calculate the P1 waiting time? It doesn't have any P1 waiting time. Yes, this is also the P1 waiting time. Now we'll see. P1 is, this is your 40, right? 40 minus previous execution time, 0. 0 minus arrival time is 0, right? 40 minus 2 minus 0, it is 38 millisecond, right? P2 arrival time, P2 varies. P2 is 5. Waiting time is 5 minus 0. Means in previous it is doesn't have, but arrival time is 5. This is arrival time. This is your arrival time. This is your previous process time, and this is your waiting time. Last process, you have to take the last process, right? So the P2, how is there any P2? No, only this P2. P1 is 2 times this and this. So the last P1 waiting time is 40 minus finishing of first P1 is 0 and minus arrival time. Arrival time of P1 is 0, right? Now the same as P2. So the P2's waiting time is 5 minus any other things are there, any other processor has P2? No. So minus 0 and arrival time is 5. So the P2 is waiting time is 0. P2 doesn't wait. When it is a 5 millisecond, P2 is arrived and it has the highest priority and it is executed. Now P3. Take the example of P3. Right? This is P3. 49. Is there any other P3? No. 49 minus 0 minus 12. Arrival time is minus 12. Right? So the 49 minus 0 minus 12. So 30 millisecond is P3's arrival time. Now take the example of P4. There are two times of P4. So what is 33 minus 5 minus what is the arrival time is 2, right? 33 minus 3. How much time is taken? 5 minus 3 is 3 millisecond it has taken, right? So the 33 minus 3 minus 2. So 28 millisecond is arrival time. Now P5 is 51 minus 0. कभी उसका execute हुई नहीं पहले. And the arrival time is minus 9, 42. Now the sum of all process divided by 5, and this will be the arrival time 29. So now this option is right? All are mostly close to the year. 29, 30, 31, 32. So it is the 29 millisecond. So you need to first prepare the Gantt chart. You need to think about these are all are the logical things. Why we need? Because when we write a program of process scheduling, so our concept should be clear that this type of process scheduling algorithm has to be executed. So this Gantt chart is very, very important to calculate the waiting time of the process, right? So now this is a 29. Now there is a next concept is their multiprocessor system, right? So the multiprocessor system means everyone's know that there are one process can be divided in number of processor. So their register, their cache, each processor has their own register and they are interacting with the bus, input output devices and the memory, right? So what is the drawback of Uni processor? It is very low performance. Single processor. What is the drawback? This is a processor. Means your dual core processor, your quad core processor, your octal core processor. So this is not the process. This is a processor, right? So the low performance, no multitasking, multiple things we cannot use, low throughput and no distributed network, because the distributed networks means no sharing devices. It is not a distributed. So that is a drawback of single process system. What is the objectives of that? To improve the any system performance through the multi-process concept, it increase the performance, multiple user needs, multitasking, it is news, multiple tasking, multiple user, multiple tasking, increase the throughput and share the hardware between the CPU and the cost, right? It is sharing the resources. That is the main important of any operating systems, right? The basic of multiprocessor scheduling, how the multiprocessors are scheduled, right? That is a main concept. In multiprocessor scheduling, multiple CPUs are available and hence the load share become possible, right? Why we called as the, we have to buy the computer of dual core, means at one processor will execute one job at a time, but if it is a dual core processor, two jobs will process at the same time. So obviously your execution speed and your throughputs are maximum application you can execute at the same time. So your load sharing becomes there, and your output will give the more efficiently. It is more complex than the single process system. Obviously everything, the writing of a operating system for dual core processor, quad core processor, or octal core processor, it is more complex than the single core processor, because you have to make the queues, job, and everything for that individual processor. Even though system is become more faster, but you will have to write the code, you will have to make your operating system in that efficient way, so the, all the resources can be utilized, right? So it is more complex than the single process system. In multiprocessor system, the system are homogeneous. We can use any processor available to run any process in the queue, right? It is a homogeneous because they are into the same environment, they are into the subcode. Dual code means two parts are there, but whichever the processor will free, so any queue can be execute that process, right? So it is a homogeneous system, sharing system, right? So the approach to the multiprocessor scheduling, there are two types of approaches of scheduling: asymmetric multiprocessing and symmetric multiprocessing. Right? So these are the approaches of the multiprocessor scheduling. Asymmetric multiprocessing means what? When all the scheduling decisions of input output process are handled by a single processor, which is called as the master server, right? So in single processor, what it is, when all the scheduling decisions of input output processing are handled by single processor, which is called as the master server, right? Because there is only one, and other processor execute only user code. This is simple and reduce need of data sharing. This entire scenario is the asynchronous multiple processor, right? Only master will handle. When all the scheduling decision and input output are handled by the single processor, which is called the master server, and other are their slaves, right? And other processor execute only the user code, and this is simply reduce the need of data sharing and entire scenario of a asymmetric multiprocessor. Whichever the processor is required the input output or any memories data, so that only one processor, master processor, will execute, other slave processor will execute only the code of that program, right? Now same as this, so the only master processor will execute the input output, no sharing of memory with this. All are the slave processor, these are the slave processor, and these will execute only the code, right? And only master processor will execute the input output and memory, no sharing of memory. Whereas symmetric, all the processor may be common ready queue of each processor, may have its own private queue for ready process and scheduling procedure. Further, by having a scheduler for each processor, examine ready queue and select the process to execute. Means each and every processor will process the queue, right? And it will share, it will execute the input output, it will execute the, it will execute the memories also. That is the symmetrical processing, right? Now this is the your symmetrical process. Even though this CPU2 is a master, but all CPU1, CPU3, CPU4 will execute any, these are into the queue, will execute any queue, and which it will share into the memory. Whereas in a asymmetrical, it is individual, only these are solving. So these are individual things. But here in symmetrical, it is into the queue, and any processor will free, so the P1 will go here, P2 will go here, P3 will go here, and P4 will go here. So according to that it will execute. This is the symmetric one. Now the last concept of scheduling is a load balance, right? How the load is balanced. Arjun, thoda charger la na beta. The load balance is the phenomena which keep the workload equally distributed across all the processor in the system, right? So it will all the processor will system. So for that it is approach of symmetric processor is used, right? The load balance is necessary only on system where the load balance is necessary only on the system where each processor has its own private queue of process and which are eligible to execute, right? And there are two general approaches of the load balance, right? So this is what in single code process, if individually it is taking symmetric, so it will not balance the load, but in asymmetrical it will balance the load, right? There are two approaches, push margin and pull margin, right? If any processor has long queue and other processor is free, so there is a push margin and pull margin, right? In push margin, a task routine check the load on each processor. If it is find imbalance, then it's evenly distributed load on each processor by sorry, by moving the process from overloaded to the ideal or less busy process, right? This is our common example when we go to the shopper stop or when we go to the supermarket. If one counter has big line, so we can go for the another counter to make the bills. So it's the same as if above that margin, so it will see which is the processor will free, so it will balance. And pull margin means was occur an ideal process will pull the waiting task from the busy process from its execution. So जो भी प्रोसेसर को लोड नहीं है, so they will pull. So most of the time they will call, yes, come, this counter is free. So same type of concept is used in a load balance. Now thank you girls. Do you have any query? Please ask me. Hello girls. It is very beautifully subject to understand the concepts.